All right, so today, 8.4, we're talking about area of regular polygons. Quick review of the definition of a regular polygon. It's a polygon whose sides are congruent and angles would end up being congruent as well. So with that, let's get into it. You can divide a regular polygon into congruent isosceles triangles by drawing segments from the center of the polygon to each vertex. So let's pause here and take a look at the diagram because that's exactly what they're showing. So we have a regular pentagon here, and they are showing us that from the center of that regular pentagon, you can draw segments out to each vertex of that pentagon. Right? And that creates congruent isosceles triangles. Continuing on, it says the center of the polygon is actually the center of a circumscribed circle. And you can see that in the diagram as well. So these congruent segments are sometimes called the radii of a regular polygon. In this investigation that we will do here in a few minutes, you will divide regular polygons into triangles. Then you will write a formula for the area of any regular polygon. So that's the goal for today, is to end up coming up with the area formula for a regular polygon. We've talked about area formulas of different polygons so far. Now we're talking about area of a regular polygon. Before we get into that investigation, we need to define the apothem. It says here, the distance A appears in the area formula for a regular polygon, and it has a special name, apothem. An apothem of a regular polygon is a perpendicular segment from the center of the polygon's circumscribed circle to a side of the polygon. You may also refer to the length of the segment as the apothem. A couple additional notes before we move on to the investigation. Be very careful not to confuse the apothem with a radii of the polygon. On the previous slide, they defined or spoke of the radii or the radius of the polygon as going from the center of the polygon to the vertex or to a vertex. Well, you can see that the apothem goes from the center of the polygon and is perpendicular to one of the sides. It's a very common error for students when reading diagrams to mistaken the apothem for a radius or a radius for an apothem. So don't let that happen to you, okay? All right, that being said, we're on to the investigation. So our goal here is to come up with the formula for the area of any regular polygon. So we're going to work through the different steps. We can complete the table, and in the end, we can complete the regular polygon area conjecture with that formula. So when we look at this investigation, let's start with the regular pentagon. They have a diagram there for us in the top right corner. We know that to find the area of a single triangle, we do 1/2 base times height. And in this diagram, the base of that triangle is S, and the height is the apothem A. So we could do 1/2 the base times the height. And that would give us the area of a single isosceles triangle. Well, obviously, to find the area of the whole regular pentagon, we're now going to multiply that by the number of triangles. Well, the number of triangles is equal to the number of sides. In this case, 5. Now, if we move on to the regular hexagon, which they give us a diagram of that, same thing. To find the area of one of the triangles, we do 1/2 the base times the height. And then to find the area of the entire hexagon, we're going to multiply by the number of sides, which is the same as the number of triangles, right? For the regular heptagon, we applied the same thinking. The area of one of the triangles is 1/2 the base times the height times the number of sides, which in this case would be 7. We could continue applying this thinking to a polygon of any number of sides. In the table, they have 8, 9, 10, 12, n, right? The key is to take the area of one triangle and then multiply it by the number of triangles that make up the polygon. And that number of triangles is the same as the number of sides. So we can represent the area formula for a regular polygon, 1/2 times the apothem times the side length times the number of sides. Or, since the side length times the number of sides would give us the perimeter, we could write 1/2 the apothem times the perimeter. So we have two forms of the area formula of a regular polygon.